Welcome viewers back to Juddy Productions. In today's video we'll be looking at VCE General Maths, Unit 3, Area of Study 1 with data analysis. Our topic is calculating the least squares regression equation, and the skill is using summary statistics to do so. Traditionally, to determine the least squared linear regression equation, one would need all the data available. That is a full set of response and explanatory variables. You then place this data into your TI-inspired CAS calculator in a list and spreadsheet and perform a linear regression to determine the equation of least squares regression. However, in some circumstances this data is not available and one has to use a summary data set in order to generate a linear regression equation. Let's look at two such examples. In task 1, we're asked to calculate the equation of the least squares regression for the following data. So we can see in this table we have the mean for x and the mean for y, the standard deviation for x, the standard deviation for y, and the correlation coefficient r. So that's our statistical summary. Let's now generate the equation of least squared regression. A reminder of our traditional linear equation, we have y equals a plus bx, where y is the response variable, a is the y-intercept, b is the gradient, and x is the explanatory variable. So step 1, to calculate the least squared regression line, is to calculate the slope, the gradient. So b is our question mark, that's the symbol for the gradient. R, the correlation coefficient, is 0.94. The standard deviation for y, the variable y, is 3.24. And the standard deviation for variable x is 2.33. Our equation to calculate the gradient is b equals r, the correlation coefficient, multiplied by the fraction of the standard deviation for y over the standard deviation for x. So we have all those variables, we simply substitute those into the equation. So r was a value of 0.94, s of y, the standard deviation of y, was 3.24, s of x, the standard deviation of x, was 2.33. When we multiply those values, we end up with a gradient of 1.31. Step number 2, we want to calculate the y-intercept. So the symbol for the y-intercept is a. B, the gradient that we calculated previously in step 1, was 1.31. The mean value for y is 33.4 and the mean value for x is 27.8. And the equation we use to calculate the y-intercept is as shown. A equals the mean value of y, take away the gradient, multiplied by the mean value of x. So we sub those variables into our equation. We end up with a y-intercept of minus 3.0. Finally, we now want to put together our gradient and our y-intercept into a linear equation. So we calculated the y-intercept a to be minus 3, and we calculated the gradient b to be 1.31. Putting both values into our least squared regression equation, we have y equals a plus bx. So subbing in, we get y equals minus 3 plus 1.31 times x. This is our least squares regression line using the summary statistic data. Task number 2. A study was conducted to investigate the effect of drinking coffee on sleep. In the study, the amount of sleep in hours and the amount of coffee drunk in cups on a given day were recorded for a group of adults. The following summary statistics were generated. So once again, we have a table with a mean, standard deviation for both the sleeping in hours and the coffee in cups, and also a correlation coefficient r. And we're asked to calculate the least squared regression equation. Now in this table, we're not told which variable is the response and which variable is the explanatory, but we can work it out. And of course, we're using the traditional equation for linear regression, y equals a plus bx. The response variable, our sleep, would respond to the amount of coffee consumed. So that is our response variable, and it's positioned on the y-axis. And the explanatory variable is the coffee in cups, and that's the variable x that would be shown on the horizontal axis. So we can rewrite those as a y bar and x bar for the mean of both the y and the x variable, and a standard deviation of y and a standard deviation of x. Now we'll repeat the process we did in the previous example. So first of all, step 1, let's calculate the slope or the gradient. So that is represented by the variable b. That's what we're trying to solve. That's our question mark. The correlation coefficient r is negative 0.770. The standard deviation of the y variable is 1.12, and the standard deviation of the x variable is 1.56. Here's our equation to work out the gradient from this statistic summary. We sub our values in, and we end up with a gradient of negative 0.553. Step 2, we wish to calculate the y-intercept. So first of all, the symbol a is for the y-intercept, that's our question mark. We know the gradient from the previous calculation to be negative 0.553. We know the mean value for y to be 708 and the mean value to x to be 2.42. Our equation to work out the y-intercept is a equals y bar, take b multiplied by x bar. We sub our values in, and we end up with a y-intercept of 8.418. Now we want to put both our gradient and our y-intercept into the least squared regression. So we have our value of a, the y-intercept of 8.418, the value of b, the gradient of negative 0.553. So we go to our equation, general format of y equals a plus bx. We sub our values in for a and b, and we end up with an equation that says y equals 8.418. Take away 0.553x. Now, unlike the previous example, we actually know what the response variable y is, that is the hours of sleep, and we know what the explanatory variable x is, that is the number of coffee drinks in cups. So we can write out the equation for the least squared regression as the number of hours of sleep is equal to 8.418 take away 0.553 times the number of cups of coffee. You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.